Hello, my dear students, class 11. Hope you are all fine and in a good state of mind and cheer. Today, we have taken a topic for you in mathematics, that is, sets, a basic concept in mathematics, means sets how to represent different sets. Okay. So, what's the concept of set? What set? In our day to day life, we use different sets. Like collective nouns, we use a flock of birds, a herd of sheep, a cluster of bananas, a bunch of keys, a gang of rubberers, a pile of books, a school of ants. All these you have learned in English grammar. The collection or a group of objects or things. So set is nothing but a collection of objects or things. And the objects are of similar nature and character. For an example, if cows are a set, can we can we include a cat in that group as a member? It is not a member because dissimilar. Okay. So set is a collection of well-defined objects. Means the objects of a set are called elements. And these elements or these objects should be well defined. Means we can easily identify these objects as per a specific rule or criteria given. Okay. So we have taken some examples for your understanding. All state capitals of India, we can identify the capitals. That is the means actually identifiable means we can easily identify the capitals like Bhubaneswar, Kolkata, Dispur, and your Raipur, Patna, Ranchi, Bhopal, like this. So we can identify and write the objects one by one. Okay. But in second example, you see all science students of your class. So we can identify the students, those who have offered science subject in a college, okay, or in a school, that the case may be. So we can identify the students and particularly science students. But students offering arts or commerce is not an element or is not a member of that set. Okay. So we can identify all intelligent students of your class. Here is a question. We can identify all students. So according to the name, we can write serial one by one. But intelligent, can we measure? What is the yardstick? So what is the measuring rod? So we do not know who is more intelligent or most intelligent. So it is an adjective and it is expressed a degree of comparison, that is intelligent, more intelligent and most intelligent. So the students are not well defined. We cannot define intelligent students. That's why we cannot frame a set of intelligent students and set up all prime numbers. So you know the prime numbers we can easily identify. The least even prime number 2, 3, 4, 5. Actually 2, 3, 5, 7, not 9. 9 is a composite number. 11, 13, 17, we have 18 here. So all the objects can be identified as per this rule, prime numbers. So what is prime number? So prime number means the number has two factors, that is 1 and the number itself. Okay, so 3 you see, 1 is a common factor and the number itself, the two vectors. So basing on this criteria, we can categorize the set of all prime numbers. So elements, you see elements or object should be well defined. Means as per the criteria, as per the principle given in the statement, we can identify the elements or the objects. So all big cities in India, okay. So there are many cities in India, but which one is big, which one is small or medium or metropolis cities? Uh, So we cannot identify the big cities. So there is no measuring yardstick or measuring criteria. So the cities we cannot identify. So the cities are not well defined because the criteria is not specified here. So the objects which can be should be well defined means we can easily identify the object basing on the criteria or the principles or the rules given therein. Okay. Then you see all elements of a set, all elements of a set are written within a curly brackets that we call braces. Okay. So let's recall. You have already learned three type of brackets. One is parenthesis, that is a round bracket that we use in English sentences just to express the meaning. We use round brackets, or is otherwise called half moon brackets. And this is called curly brackets, and it implies set of all, means it contains all objects or elements. That's curly brackets, and otherwise called braces. But another bracket is called box bracket, that is called square bracket, and we use in mathematics. Okay. So for writing sets, we use braces or means the curly brackets. Okay. So don't be confused with braces. Then you see the sets are expressed. The nomenclature of the set. The sets, all sets, we can express using English alphabet A, capital A, B, C, X, Y, Z, Q, M, N, like this. So these are the symbols, they denote, they represent a set. So if A is a set, the elements are specified, and B is a set, the elements are specified. So we denote the sets in terms of A, B, C, X, Y, Z in capital letters. Then you see this symbol has been derived from Greek, that this symbol denotes belongs to. Suppose suppose here you see 2 is an element of set P. Now capital P. So 2 belongs to P. That means 2 is an element of set P. So 3 belongs to P. 3 is an element of P or object of P. So this symbol denotes to or denotes belongs to. And this symbol implies doesn't belong to. Okay? Not belongs to or doesn't belong to, as you say. Okay? But you see, there are two methods to represent or to write the sets, means they are elements. There are two ways, two methods. First method is roster or tabular form, and second one is set builder or rule form. Okay. So before going to the roster form or set builder form, so let us discuss this one. So X is an element of a set. Okay. This symbol small x. Remember, small x denotes an element of a set. And X bar, this actually implies X such that, means it indicates the property of that element, the character of that element, X such that. And in other way we can write X colon, same thing, X such that. In some books you can find this symbol, in some books you can find this symbol. You need not be worried. And this is braces. All elements are to be written within the braces. within two curly brackets. Okay. Then in roster form and set builder form. So we have given some examples. Set up all prime numbers. Now prime numbers well defined. We can easily define the elements. So let us define. So the least prime number is even prime number. The least even prime number 2. Then 3, 5, 7, 11, 13, 9, 17 and 19. Okay. So on. So these are the elements of a set denoted by symbol capital P. It implies set of all prime numbers. You see, to separate the elements, commas, we have used commas. So here comma. So comma separates two elements. Two elements. So to separate, we use comma. So 2 and 3, 1 comma, 3 and 5, 1 comma. Okay. So we use commas to separate the elements. This is very important. So this is otherwise called listing all elements serially. Maybe in order, so listing all elements of a set. Okay. This is the roster form. But in roster form, it is too difficult and time taking to write, and it is not convenient to represent a set in roster form because we have to list all elements one by one, giving comma between them. Okay. Now you see set builder form is otherwise called rule form or standard form. So according to some rule we can write. Now you see P is a set of prime numbers. Okay. So denoted by a symbol capital P is equal to X. X is an element of that set such that, see this line indicates, this bar indicates such that. So that means the property or the nature of the character of that element. X is a prime number. So all prime numbers are the elements of this set. So X may be 5, maybe 7, maybe 11, maybe 13, whatever it may be, it belongs to the set P. So all prime numbers are the elements of set P. So X is a prime number. Irrespective of any prime number, it is an element that belongs to set. Okay, and this symbol is used. Come to the second example, set of all natural numbers. So natural numbers, this set is denoted by capital N. So natural numbers we call the numbers counting numbers. So it starts from 1, not from 0. So natural numbers starts from or begin from 1. 1, 2, 3, 4, 5, 6, 7 and less up to infinity. Okay. So in roster form we have to write, and it is impossible to write all elements by roster form or through a roster form because we have to list all elements using comma as per our rule. But if we follow the set builder form or the rule method or the standard form, then it will be easy for us to write. So you see n is equal to x. X is an element of set n. What is the nature of x? So x belongs to n. It may be 4, 3, 5, 6. It belongs to n means x is an element of n. X belongs to n. Okay. So you have to complete here the bracket. So that should be within the two curly brackets. Okay. Two bracket, two braces. And this can also be written as x, this colon. This colon implies that n is a set and x is an element. X such that x belongs to n. The same thing. But in some books you will find this symbol, and in some books, particularly in ancient books, you will find this symbol. You need not be worried for that. Come to number 3, set of all negative integers. So you see 1, 2, 3, 4, 5, 6, etc. Right? From 0 onwards towards right, these are called positive integers. Okay? Set, set of all negative integers. Okay? Set of all negative integers, these are positive integers. 0 is neither positive nor negative. Then negative integers is denoted by a symbol z minus. So it begins and starts from -1, -2, -3, -4, -5. You see, 0 is neither negative nor positive integer, but 0 is an integer. So you see, this is a z set. We have represented, we have expressed, means following what method? The roster method, or this is called tabular method, listing all elements using commas. So we cannot write because it is endless. Okay. So we have to follow the rule method or the set builder method. In the set builder method, you see z minus is equal to x. The curly bracket begins x. X is an element of z set, z minus set. So x belongs to minus z. Minus z means set of negative integers. Okay, it may be -2, -3, -4, -5, whatever it may be. In the same way, in the same logic, we can write x. X is an element of z, and solve that x belongs to z minus. Okay, z minus means set of negative integers. So applying this rule method, we can express the set of all negative integers. Now come to the number 4 example, set of all rational numbers. Now you know, you have learned in class 9 and 10, the rational number is expressed or represented by symbol q. And we also in set, we represent rational number by the symbol capital Q. So Q represents rational number, and the form of rational number is P by Q, that is numerator and denominator. But the condition is Q is not equal to 0. If Q is 0, then the result will be infinite. Okay. So P here, P belongs to Z. P belongs to Z means all integers, positive integers, negative integers, or including 0. But Q belongs to only positive integers, means begins from 1, 2, 3, 4, 5. Okay. So here the condition is P by Q, P by Q is an element of set Q. Condition such that P belongs to Z, means set of all integers, and Q belongs to only set of positive integers, excluding 0. You see, 0 is not here. So this is the rule method we can represent, that is set of rational numbers. Now come to the last one, set of all whole numbers. So whole numbers, you know, there are natural numbers. When 0 is added, that we call whole numbers. A set of whole numbers. And whole numbers is denoted by symbol W. You have learned it in class 10 and 9 also. So W is equal to, you see, as per roster form or tabular method, 0, 1, 2, 3, 4, 5, and so on up to infinity. Okay. But as per rule form or set builder form, we can write W is equal to, the curly bracket begins here, the x. X is an element of set W. So that x or that is the nature or character or property of set x. X belongs to W. So it may be 0, it may be 1, 2. So it is an element of set W set, means whole number. So x is a whole number. Simple, it implies x is a whole number. X belongs to W, means here x is a whole number. Hope you have all understood the concept of sets and two ways for its representation, for their representation. That is, one is roster form. In roster form, we write all elements or we list all elements within two curly brackets, and we use each element, we separate each element using a comma. Okay. But in set builder form, that is called rule form, we apply the rule which clearly identify, means the objects that are well defined. So the logic or the rule is expressed in this set builder form. That is called rule. The rule is spelled, the rule is represented, the rule is expressed in set builder form. So from this rule, you can easily find out, you can easily visualize that this is a set of natural numbers, it is a set of prime numbers, it is a set of rational numbers. Okay. So these are the common symbols that are used how to write sets. Okay. So sets that plays a very important role in mathematics. Hope you have understood the basic concept of sets and their representations. In our next session, in our next video, we shall present types of sets and their natures and characteristics. Stay tuned to watch our next video. Stay tuned, please, to watch our next video. If you like, you may subscribe to our channel and our handle at the rate MNMP2024. Thank you all for watching, and we invite your cooperation, your suggestion, considered opinion, and feedback for our improvement.